love sim racing, and I spend a lot of my free time in my home-built racing cockpit. But I'm not happy with my current wheel when it comes to Formula 1. It's just too heavy. I've used SOLIDWORKS to design a smaller diameter, more realistic wheel that keeps all of my existing functions like buttons and shifters, while eliminating all of the hardware and integrating the button boxes into the wheel itself. This will reduce the weight and rotational inertia, but I'm going to need to optimize my design so that it's as light as possible, but still able to withstand the forces of my wheelbase. If you build products for the real world and it doesn't work, it's a failed product. This basic concept is something that all good designers understand, and it's a lesson that I've learned long ago. Unfortunately, this process of building and testing prototypes can add significant cost and time when developing new products. Today I'll show you two different workflows included in Simulation Professional and Premium that you can use on your next design. First, I'll make use of the trend tracker to keep a log of any manual changes that I make, allowing me to go back to any previous iteration after setting a baseline. Then I'll show you how optimization can use any existing simulation studies to find optimal values based on my own goals and criteria without needing to make these changes manually. Now, simulation may not eliminate the need for physical prototypes, so to be sure that my design works, I'll 3D print my model on our Stratasys 3D printer and test the prototype. My goal is to make the wheel as light as possible while still retaining enough strength to handle the forces produced by the servo motor. I also want to account for some added torque by the user twisting around the main spoke. Since this will be a 3D printed part, I want to keep the factor of safety rather high because the print will use only 40% fill to lower the cost and print time while keeping the part as light as possible. I'll shoot for a factor of safety goal of about 5 since I'm only going to have one shot for this weekend's race. My static simulation study shows an initial factor of safety of around 8, so there's a lot of material that I can remove. Now I know I need to make some changes. To keep track of how they'll affect my simulation, I'll use the trend tracker. I simply add it to the study, and since I've already run a simulation on the model, I'll set this as a baseline considering I want to improve from here. Trend Tracker initially adds mass, stress, and displacement to the journal, but I also want to track factor of safety. This data comes directly from a SOLIDWORKS sensor. Opening the trend journal, I can see that the baseline test has logged all the current values. The journal will keep track of all my changes and compare them to a baseline in the future to tell me how much better or worse each change is. After adjusting the thickness and rerunning, simulation asks me if I want to track this new change. Opening the trend journal again shows that my mass is about 26% lighter, but my stress is increased by about 300%. If I would have made this as a prototype, the design would have failed. Simulation has already saved me time knowing how far I can take the thickness. Trend Tracker also tracks each sensor on a graph, giving me insight into how these changes will affect the model. After another change, I'm just above my goal and I've shaved about 13% off the mass. I could continue to manually iterate the model, and if I ever decide to roll back to a previous iteration, simulation has kept track of all of them for me, saving a ton of time without needing to remember the values I used, but also saving the study so I can start over and try other changes. I don't want to manually keep making changes. I need to get this done quickly. This is where optimization studies can help. I want to optimize the base thickness, so I'll add it to the list of variables. Next, I define the range of values for this variable. I also need to set the steps or amount of change between each iteration. That will define the total number of scenarios to test. In this case, there's going to be 9 total scenarios. Next, I'll define the constraint. Remember, I decided that my factor of safety should be above 5, which will tell the simulation whether the test passed or failed. And finally, I add a goal to minimize the mass, which will give me the best possible feedback from my racing simulator. The last thing to do is start the optimization study. I can see here that my simulation is running, adjusting parameters, and then rerunning the study. All of this is automated for me, allowing for a hands-off approach to simulation. This could be run overnight or a lunch break depending on the complexity. It looks like I had a failure on scenario 4 and 7. I can go back and look at why it failed later, but if any of the features on my model failed to rebuild properly during the simulation, the study will not solve that scenario and logs it as failed. So it's important that I have a good parametric model that will rebuild successfully for all scenarios to eliminate any gaps in this data. Once finished, I can look at the history of scenarios from these graphs, or alternatively, I could look at a specific scenario and view the results to see how it's better than the rest. The study shows me that scenario 2 is the best with a factor of safety of 5.1 and about 14% lighter than my original design. This should work perfectly. Now I need to print my design for testing. I have a Stratasys F370 in my office that I'll use to print the prototype. I simply need to drag and drop the SOLIDWORKS model into GrabCAD Print, adjust the orientation, define my print settings, and prepare it for print. This process only takes a few minutes. Now we can check the printer and send the job to the queue. Alright, I'm here at home in my racing cockpit, and now it's time for some real testing. The print took just under 8 hours to create with a final weight of only 180 grams. This is a pretty significant weight savings over this heavy automotive wheel I've been using. Each wheel type serves its purpose, with the new version allowing much quicker inputs due to its low weight. But the real question is, will it hold up? After 20 or so laps around one of my favorite tracks, Spa-Francorchamps, it's clear that the weight savings gives me a much better feel from the forces of my wheelbase, while the smaller diameter intensifies the torque, giving me a much more immersive experience. Thanks to simulation, I have no doubt that it will hold up to many more laps. The 3D printed prototype also allows me to test one factor I couldn't test for in simulation: the feel. I'm very happy with the part, and the whole process from concept to design to print to testing only took me 3 days. Why does all this matter? Well, let's think about it. How many prototypes do you make for just one product? How much did those prototypes cost you? If you could shorten your development cycle by just one prototype, could you afford SOLIDWORKS Simulation? SOLIDWORKS Simulation Standard is an easy step that you can take to help ensure that your designs are strong enough to handle their real-world environments. But what if you want to go beyond ensuring that your designs will work and optimize them for a variety of considerations? Then it's time to take the next step to Simulation Professional. Give Computer-Aided Technologies a call, and we'll help you prepare for your next product cycle, saving you time and money by virtually testing your next design. Thanks for watching, and we'll see you next time.